Clark, let me make you a host so you can share your screen if you're planning on doing that. Okay, you should be good now.
Well, hello, everyone. I'm Clark Zeit, like you said, from Medical Technology Associates. I got into medical gas stuff about 20 years ago in 2000. Before that, I was a respiratory therapist. My first exposure to medical gas was actually the hospital I was working at. I came in for my evening shift, and I was told by the respiratory therapist that was coming on that they'd actually ran out of oxygen. So that I figured, I was like, how does that happen? Well, a few years later, I ran into a gentleman that was doing medical gas. And I started talking to him. He said, well, actually, that should never happen because they should have some set of alarms and things like that. And I piqued my interest. So I got to talking to this gentleman, and I started working with him. And so that's kind of how I got into it. So I've been doing it for a long time. And every time I think I know this job and know it pretty well, it always humbles me. And I find something else out that there's a lot of gray areas in the book. We get to know the book, and then every 3 years a new book actually comes out. So it's a always evolving type of industry. So it's never a dull day. So with that, right now I'm going to talk about the three major type of inspections that we do when we're from MTA and for the fire marshal's office. The first inspections we will do is a fairly new one. It's a rough-in inspection. So if you have a new hospital being built or you have a renovation going on at your hospital, as they're installing the piping before they start closing the walls, there should be a rough-in inspection done. And when they do the rough-in inspection, we just want to make sure that they use the proper materials. We'll evaluate the locations of the alarms, valve boxes, outlets, and things like that. That's a fairly new inspection, so it's 50-50 on it. Depends on the new construction, what code it was actually built under. So that is one of the inspections we do. Once the construction is complete, we will do a verification on any new construction that was done. That will be doing outlet testing, alarm testing, verifying pressure tests for leaks and things like that. And so anytime we cut into the pipeline, we need to have a qualified 6010 plumber doing that, not just any plumber, it's actually an ASAC credential. So you need to make sure that your company that you have working in your facility does have the proper credentials to work in healthcare. And then they have to be using clean and piped fittings. So we don't just go to the local hardware store and buy fittings. They actually have to be clean for medical. They have to have the proper markings. And then all the accessories we have to be approved for medical gas. So your alarm panels, your valve boxes, and everything like that. There's a lot of general manufacturers that have it. Amoco is very big in the state of Kansas. You guys might have some Allied stuff. Ohio and some of the older hospitals. Beacon Medeas is a very big producer. And then you have Ohio and PowerX and some others, but that is generally the type of manufacturer that you guys will see when you guys get your new areas. Some of your older areas has a lot of Ohio stuff. Out west, you'll see a lot of older Ohio stuff. And then the finals inspections that we do are annual inspections. So on an annual inspection, we'll go in. Currently, the state of Kansas is under the 2012 edition of Nfpa. And under the 2012 edition of Nfpa, we should have our medical gas systems reviewed on an annual basis. Typically, that means that you'll have a company like MTA, there's Advanced Compliance Plus, AirSafe, there's several good companies that run around here that do these inspections. And what they'll come in is once a year, they'll come in and they'll verify that, do outlet testing, verify alarms are working correctly, look at your equipment, make sure it's being maintained properly, look at your exhaust and your intakes. They'll basically do an overview on the whole system. When we do the overview on the whole system, the state of Kansas is under the 2012 edition, which will look like this. And if you don't have a copy, you can Google it and get a copy. And it would be a good idea for everybody to have a 2012 edition. The reason you want to have a 2012 edition is when we cite something, you're going to want to be able to look at it, verify it, or if you're putting in new construction, it will have to at least meet the 2012 edition. Every 3 years, except for 2005, we get a new edition. So right now we're under the 21 edition. So it's like that. Most new construction that I'm certifying right now is still under the 18, because as you guys know, we're going to want to do a renovation on an area. And when we do the renovation, it goes to the architects and the engineers. They talk about it. We get a budget set for it. So it's usually a long process. So most construction certifications we're doing is under the 18 edition. And for new construction, we do see a few 21s, but it's not very rare, even though we're in 2022. It's not common for us to see a lot of 21 stuff so far. But when we're talking about hospitals and things like that, when we come in or any company comes in, you're going to want them to make sure they're inspecting to 2012. And that is what CMS adopted, and the state of Kansas followed suit and adopted the 2012. So if you get an inspection done and somebody's citing from anything other than 2012, you're going to want to say, hey, look, that's what I'm currently I'm being held to. I will tell you that when we do annual inspections, we get into a lot of, it gets very difficult, because we will have a lot of areas that were built before 2012. And every edition of Nfpa states that any system not in strict compliance with this code can remain in use as long as the authority having jurisdiction doesn't deem it a hazard of life. Well, we have a lot of hospitals that were built way before 2012. And when we get into that, you can find zone valve boxes, a frequent thing, that don't have gauges. I don't think that's a hazard of life as long as the valve is working and not leaking. That's usually a recommendation that you will see. So usually when you get your report, you will get a list of deficiencies typically and recommendations. So if I do a renovation to an area, I recommend you put a zone valve box in with a gauge. Or if it's a deficiency, it would be something that your inspector at the time has deemed that, hey, you have a leaking oxygen outlet, that's a fire hazard. It could be a patient safety issue. That's a deficiency. Let's get it fixed within our 45-day window. A recommendation is typically something that I say, hey, you don't have a zone valve box gauge on this area. If you're going to renovate it, put one in. So you guys, and every company does it a little bit different, but you're going to get this 45-page report, and the biggest, most important thing that you're going to want to look at is your deficiencies, and you're going to want to address deficiencies and look at your recommendations. Because if you're planning on doing any renovations to an area, look at what might be in your recommendations. Your engineers should look at that, but there may be, it also says that when we're doing a renovation, we only have to bring up to code the portions of the system we're directly affecting. Well, that's a very subjective term. So I do have a lot of engineers that'll say, well, I don't really need this or that, but it may be a time, and I'm going to go ahead and throw that watch away because I don't know how to mute that. So you might find you have a recommendation on your annual that isn't going to be addressed during new construction. That would be something that you guys would want to look at anytime you have new construction occurring or anything like that. So that is the general base of the type of inspections we do. A lot of things that we are seeing that are when we do our annual inspections are exhaust for vacuum pumps, intakes. One of the things that is in 2012 that was pretty new, because we literally went from the 1999 edition of NFPA to 2012. So we had a lot of changes between that, and there's a lot of different versions. One of the big things that I see is we have a lot of intakes and exhaust that don't meet the 2012 requirement. They'll be too close to another intake, exhaust. And when you're evaluating those type of things, remember, if we are manufacturing medical air. We're taking air from the atmosphere and we're making it a medical grade air. So when we do that, we want to make sure we're intaking our air from a very good place. We don't want it close to any vacuum exhaust. That's a completely disgusting thing. So we do want to look closely at your intakes and your exhaust. And your exhaust for your vacuum, you got to remember, we're exhausting vacuum from COVID patients, possibly TB patients, and disease patients. So we don't want that by any other intakes. So that is one of the biggest things that I see when we go to do the inspections. So that is one of those type of things where you're going to want to look at your intakes and exhaust and make sure they're at good locations. And it is 25 feet. It's 10 feet from any door window opening, but it gets 25 feet on some of these from other exhausts and things like that. And I do realize that it gets impractical sometimes to actually meet the 25 feet just because of other exhausts and things like that, and intakes from air handlers, whatever. If you do get in a situation where it's impractical to meet that, you can always remember in that book, it says that anything not in strict compliance, you can ask your fire marshal, hey, look, I have an exhaust right here, but it's by a relief line that's a closed relief line. It doesn't exhaust in the building, anything like that. So just remember, if you're in an impractical situation, or if it doesn't make sense, you can always talk to the local authority having jurisdiction and say, hey, look, I want to get this to here to there, and they will have the ultimate say on what you can and cannot do. So there are always provisions there for changing things up. One of the biggest things, especially in some of the older hospitals, 10 plus years, we have a lot of nurses and respiratory therapists and staff that will hang 15 things from an oxygen outlet, and they'll cause them to prematurely leak. A leaking oxygen outlet is something that you're going to want to address immediately. Any leaking outlets is something that you're going to want to address quickly, because it's a patient safety issue, fire hazard issue. A vacuum flow is another one. Vacuum has to meet a certain flow requirement. If we go into test and it does not meet that requirement, that is going to be something that you're going to want to address immediately. Because if you have a code and somebody's trying to use suction and it doesn't have enough suction, that's going to be a patient safety issue. So there are many things that we're going to look at and talk about, but outlet testing is one of the things that you should see. But you're going to get a wealth of information that you will not use typically on an annual inspection, because you're going to have sheets of all your outlets listed, zone valve boxes. The biggest thing that any good company should be giving you is a specific list of items that they think are deficient or need to be addressed right away. Some of the other issues some of the other things you guys want to look at is you want to be making sure that you are maintaining your equipment per manufacturer's guidelines. And one of the biggest things is that if you have a medical air compressor, it is going to have two monitoring pieces of equipment on it. It's going to have a CO monitor and a dew point monitor. A CO monitor, depending on the manufacturer, will need to be checked once a month or every 3 months. Most manufacturers are every 3 months. To check a CO monitor, you have to acquire cal gas, and you will have to calibrate it via manufacturer guidelines. The bad thing about a CO monitor, when a CO monitor sensor goes bad, it doesn't go bad and say I'm bad. It literally goes bad and says I'm just not going to read CO. That's why it's extremely important that you're checking those per manufacturer's guidelines. Because if somebody's burning a field, or we're doing some work with a air compressor up on your roof and they're throwing exhaust into your medical air, the only way we're going to know that that's in there is if we have that monitor properly working. So that is one of the biggest things that I highly recommend, that if you have a medical air compressor, make sure you are doing the proper maintenance on the CO. The dew point monitor is another very important part of that. And the dew point monitor monitors your moisture level in your air. And a dew point monitor sensor starts to trend bad. They don't go bad right away. If they go bad, usually they'll signal. You have two things. They'll either signal that they're at 88. If you see your dew point at the negative 75 and you look at the sensor and it's a range from plus or minus 75 and it's at negative 75 and never changes, there's a good chance that monitor has quit talking. The only way you verify if the dew point monitor is properly working is you'll need to have someone come in and check your dew point. So when somebody comes in and does an annual inspection, one of the things they'll do is they will put a device on that will check the CO level, the dew point level, they'll check for particulates, hydrocarbons. So they will do a quality medical air check. And so that is why you want to make sure you're keeping up on your equipment recommendations. You can usually, if you don't have manuals for your equipment, you can usually go on the internet, find it. If you have a air compressor, usually you're talking about belts and filters once a year, and your CO is going to be depending on manufacturer. And then your dew point, you want to check at least once a year. You can buy the monitors online, but then you're going to send them in for calibration. It's probably easier to have a third party come in because they're going to be required to maintain their equipment properly. On your vacuum pumps, depending on what type of technology you have, if you have an oil lube pump, usually you're changing your oil every 500 hours. You can put synthetic in it, go every 1,000 hours. You'll have some exhaust filters that'll be once a year. And then you will have a coupling between your motor and your pump, and you're going to want to check that or replace it once a year. Claw pumps are usually once a year. Dry vane pumps are once a year. So the biggest thing for that we want to make sure is we're maintaining our equipment properly. We're identifying any deficiencies that could be patient safety issues, and we're addressing them immediately. And then when we're doing renovations, we want to make sure that we are addressing any recommendations during any of those deficiencies. So that we'll talk about gas storage. So if we have two different types of gas storage. We have an indoor high pressure cylinders. That would be typically, if it's a small hospital, you could have an oxygen manifold, a nitrous oxide manifold, a nitrogen manifold, and sometimes a carbon dioxide manifold is typically what we see in this area. Your indoor storage facilities are going to need to be 1 hour fire rated walls, a 45-minute door, and you're going to want to make sure you have proper signage on your door to identifying that room. There's two types of signs. And if your local authority have jurisdiction says, no, I want a triangle on there, Nfpa has a 3-line sign and a 5-line sign. If you have oxygen and air, you can do a 3-line sign. If you have just nitrous oxide, nitrogen, you're going to have a 5-line sign that's going to indicate before you enter this room, you may be deficient of oxygen, let it vent. So typically, if we have a high pressure manifold room, and you get, so what you will have is a high low pressure switch or a pressure indicator that tells what the pressure is, and a reserve in use. So if we go from if you have a 5x5 oxygen manifold and we deplete from one side, you should have 2 master alarm panels, one in a surveillance area of 24 hours. Smaller hospitals are usually ERs, PBX, if they have a 24-hour PBX, and then one is in the primary work area of the individual responsible. That's usually in your maintenance office. If you have one, you have a newer facility, this happens a lot, where they'll put a master alarm panel. They'll say, we're going to put it in this maintenance area, and you're not going to be in that area. You will want to make sure that you're going to have someone looking at those alarms at all times, at 24 hours a day, because if you run out of oxygen in the middle of the day or the middle of the night and you come in and we didn't call air gas, we could possibly run into a situation where, hey, we don't have any oxygen or any of the other support gases. So it is very important that our 2 master alarm panels are going to have at least 24-hour surveillance. And when we have our 24-hour surveillance area, like I said, I have had areas where we ended up relocating one to surgery and we have one in PBX. That's your minimum standard. So they don't always have to, if you guys, especially in smaller hospitals, probably don't spend a whole bunch of time in your actual shop. You're actually out working in the thing. It might be best to put one at the nurse's station and one in the ER. So just make sure that you have those 2 alarm panels monitored, and make sure that whoever's monitoring understands if anything goes wrong on these alarm panels, you need to call us so we can address the situation. Because not only will we have our master alarm panel monitoring our gases, but it will also monitor our vacuum pump and air compressor. So if we have a high CO level, we should be getting at our master alarm panel. A dew point issue, we should have that at a master panel. And we should also have not only monitoring that, but it also monitors our pumps and our motors. So if we have a pump or motor go down, it's going to give us an alarm that indicates, hey, I don't have, I'm asking for my second pump, but it's not giving it to me. So we would get a lag alarm. So that's why it's extremely important that you would have mechanical failure in the middle of the night. You'd want to know before surgery gets started or anything like that. So on the master alarm panels, and that's one of the things that when they come in and do their yearly inspection, they will check to make sure everything's working properly on those. And they do have on a lot of these alarm panels, they're getting older. Your enunciator will go out, so you won't get a beep. It is always a good idea once a month there's a test button on almost every alarm panel that you have. You have master alarm panels like I just talked about, and you'll have area alarm panels. Area alarm panels will be required in any area of critical care or life support or anesthetic locations. Those are just going to monitor the areas in which the alarm panels for ICU, ER, ORs. Once a month, it is always a good idea to go hit your test button to make sure it's working. It'll usually give you an LED. It'll check all your LEDs, checks the audio. Depending on the age of the alarm, it'll tell you your high lows. And it's always a good idea to make sure you are at least checking those once a month. You'll do your daily rounds on your equipment and then documenting your pressures on your manifold. So if you see a manifold about ready to switch over at 200 pounds, it switches over 150 at 3 o'clock. It's probably best to go ahead and switch it over now. That way we're not getting that call in the middle of the night. So when it comes to maintaining our equipment, we want to do manufacturer's recommendations. We want to make sure that we are checking our equipment yearly, for proper function. Some of the other things that we're going to want to make sure is that our valves, sometimes one of the biggest things that I see engineers missing is when they're designing a new thing, our zone valve boxes, every outlet in your hospital should go through a shutoff box or a zone valve box. The zone valve boxes should be immediately outside the area in which they serve. So if you have your 12 patient rooms, probably in the corridor, you should have a zone valve box that does, and it should be labeled properly. If it's a newer one, it'll have a gauge. If it doesn't have a gauge, make sure that it's properly labeled. It's always accessible. One of the big things that we do in surgeries, we will stack 15 things in front of it and you cannot find or see it. I see that a lot with area alarm panels as well. So you want to make sure that what you are keeping those areas clear so you can find the alarm panels and you can get to any of your shutoff boxes in case of an emergency. So if you see someone stacking the dialysis machine or whatever in front of it on a regular basis, mark it so you're not putting anything. It specifically says they should be accessible at all times in the code. So that's not just a recommendation, that is a requirement that we need to make sure that these valves are properly labeled and that they are accessible at all times. And what I'll find a lot of times with our area alarm panels and our ORs is they'll stick the printer right behind it and things like that. So you just need to make sure that you are make that accessible and make sure your staff knows that, hey, if you, in case of an emergency, there's a shutoff box that is out here. So they need to know where the area they work in, where their valves are located. So we'll have the zone valve box located for every outlet it serves on the same floor it's on. So you won't have a valve box on 2 feeding the outlets on 3, unless you're a very old facility, and that's something that would be something you'd want to address. So we have our zone valve boxes inside the facility, and then at each piece of equipment, we will have a mainline shutoff valve. So if you had a major fire in the hospital, you should be able to go to each source equipment, and there will be a valve immediately downstream of that equipment that will shut off the entire hospital. Obviously, we'd only be shutting that off in case of a major catastrophe. So we have our bottle storage rooms. Our bottle storage rooms have a limit. If we go over 20,000 cubic feet of gas, we will be required to do a bulk oxygen or a bulk storage tank. 20,000 cubic feet, if you average out about 250 feet per cylinder, you will get a good idea. They've ranged a little bit less than that, but if you put 200 feet per, or 200 cubic feet per cylinder, add it up, and if you're over 20,000 cubic feet, you're going to want to either get an outdoor storage facility for some of them, and that's in use and storage. We want to make sure that those are always secure. They do not have to be individually secured, but you'll need to chain those up so they'll prevent them from falling. And you'll want to make sure if you get over the 20,000 cubic feet, you're looking for provisions to not be over 20,000 cubic feet. If you have a liquid oxygen manifold with a dewar, those are about 14,000 cubic feet per, or I'm sorry, 4,700 cubic feet per dewar. So if you get 4 or 5 of those in there, you're going to get really close to your 20,000 cubic feet really quick. So you want to make sure that you're monitoring how much gas you're storing in that particular facility. If you are a bigger facility and you have a bulk oxygen site, you will be remote from the building. They will have a source valve out there. And then when it immediately comes into the building, you will have a mainline shutoff valve. And it directly downstream of your mainline shutoff valve, you should have a pressure gauge and some sort of sensing device that tells you if it goes high or low. Our oxygen, air, nitrous oxide, and sometimes typically carbon dioxide run in our 50 to 55 range. Our nitrogen, which is a support gas we usually use for tools, runs about 180. Our oxygen, air, and vacuum, or our oxygen, air, and nitrous oxide go high at 60 typically and low at 40. And nitrogen 200 and 140. So it's 20% above and below normal pressure. So if you're getting an alarm and you're getting a high alarm, it's a pretty good likelihood that you've lost a regulator. A lot of our category 1 facilities will have dual regulators. They will be able to be isolated. If you have a failure, you should be able to look at your manifold, figure out which regulator you're going through it, and switch it over so you can always service your equipment without shutting services off is the goal on our category 1 facilities. Category 1 facility is any facility that if we lose a service, someone could die. Category 2 facility is you could have a major injury. Category 3, you could have discomfort. Category 4, there's really no likelihood of that. So almost every hospital, whether you're doing surgeries or not, we're going to put them as a category 1 facility. And that means that everything will be redundant. You'll have 2 compressors, 2 vacuum pumps. If you're bigger, you may have more. That's minimum requirements. You'll have dual regulators. On your bulk site, most places rent your bulk site from your provider. If you start having issues out there, you should have a 24-hour technician on call from your provider. Should you be getting regulator problems, relief problems, anything like that, typically it is best to call your provider and they will have someone come out and look at it. Anytime we go remote on any of our gases, we're going to need to have an emergency oxygen fill box. It'll be mounted on the outside of your building. It will be used in case of something, we'll say a tornado hit and it took out your oxygen farm. It will give us an auxiliary connection for the oxygen, and it will pipe right into your oxygen, and it'll have, anytime we're doing renovations on that, if you don't have one, that is going to be something you're going to want to look at installing. Your emergency oxygen fill boxes or one of those things that are going to sit there and hopefully never get used. But if they're doing maintenance on it, doing upgrades, anything like that, it'll sit on the outside of the building. It'll be clearly identified with markings. You'll need to make sure it's locked so not anyone can come up and hook up to it, because you can literally open that box, hook any gas you want to it, and feed your hospital with it. So one of the biggest things that I see a lot on that is not properly secured. So make sure they have a spot for a lock on it. Make sure you have a lock on it. Usually if you have a provider and a bulk oxygen tank, it is best to get a lock from them. They have a universal lock for their gate. That way, if anybody's going to be using that, it typically will be your provider. So you should have a key for that gate anyway. And then, so as we're talking about the manifolds, I'm kind of going back and forth, and I do apologize. Whenever we have high pressure gas, oxygen's at 2,200 pounds, air's at 2,200 pounds, Nitrous oxide and carbon dioxide run about 850 pounds for full tanks. The reason we have the discrepancy between the gases is oxygen and air are actually in a gaseous form in there. The nitrous oxide and the carbon dioxide are actually a liquid form inside the cylinder. It's a stable liquid, but it will expand with temperature and contract with temperature. So we have minimum temperature requirements in our manifold rooms. 20 degrees, we don't want it to get below 20 degrees, and we don't want it to get above 130. And the reason why is because obviously our gases, our nitrous oxide, you could come in one day and it's a nice sunny day at 60 degrees, and we have 870. You come in the next morning and we didn't have any type of heating in that room, and it could be down to 400. So it does affect the gas on those two particular gases. That's why we want to make sure we're maintaining a certain amount of temperature in there. And as we condition that air, we want to make sure that we're not conditioning it with a space heater. So we want to make sure we're doing with indirect heat, steam. If you do have a space heater, make sure it's either ceramic or explosion proof, because you do not want that element of over 150 degrees being exposed into that room. So how you condition that room is also important. We want to condition our room. We need to have exhaust a foot from the floor, and we need to have makeup air, and it needs to be conditioned. One of the things about a high pressure cylinder and these manifolds are that we do have relief valves. We have typically 4 regulators on a manifold. You'll have a primary regulator set and a final line regulator set. And both of those regulators are going to have relief valves on them. If it should fail, we don't want to hit our pipeline with more than 75 pounds. So anytime we have relief valves on there, they need to be piped to the outside, turned down and screened. Typically they don't get used very often, so we want to make sure the screen is always on there. I see people use cloth screens and they get eaten up, so that is something you're going to want to check at least on an annual basis, is go look at your relief lines and your exhaust and your intakes and make sure your screens are on there, and they're not on a vacuum. I've seen on vacuum pumps, they start to get clogged. Back pressure is a very big enemy for vacuum pumps. So you do not want any back pressure. You don't want to suck anything into your air. So those are extremely important to make sure that they are properly screened, and then that they're ran outside. If you have a failure on your manifold on a regulator, if it's the inside of the room, you're going to get a alarm. You're going to walk in there, start looking around. You can be in an oxygen deficient environment, and before you know it, you could pass out or even worse, die. So these just aren't requirements. They're for your safety as well as for patient safety. So I always tell everyone when I'm doing inspections, we want to make sure that when we're looking at things, we're going to look at it from a couple different perspectives: patient safety, occupational health, and maintenance. So most of the requirements that we have are going to be based on fire protection, but at the end of the day, you want to make sure that everyone that's going to be around this equipment, working on this equipment, is safe. And if we have any failures, we can make sure that we are able to maintain or without losing service. There would be nothing worse than going to the surgery manager and saying, "Hey, so we're going to be without oxygen in a few minutes. So, or our vacuum pump just shot craps." I would not want to be in that conversation. That is the premise behind why all these requirements and things are there. It's for safety. And I may sound like a broken record, but at the end of the day, we want to make sure we all get home safe. And then if you end up in that hospital, you want to make sure that it's safe for you, and it's safe for anyone or any of your family members to go there. So with that, I'll gladly take any questions.
Yeah, we may sound like a broken record as well, Clark, but that's exactly our focus also. So well said. Absolutely. I've got a couple of questions in the chat. Somebody was asking if there are videos available somewhere that shows proper transportation of medical gas, so they could show the employees.
I think you should be able to find some of that stuff on DOT. The Department of Transportation will have a lot of that stuff. Because for us and for my focus, it's central pipe systems. So when it comes as far as transporting them, you'd probably be best on trying to look up for something on the DOT.
Okay. Another one, who does I'm sorry, was there a question about that or heard somebody breaking through, but okay. Who does the 3-month CO testing? Can the facility do that? Do they have to be certified?
So when it comes to working on this, in order to work on any of your equipment, you have to have at least a 60/40 credential. So the credentialing goes like this: 60/10 is an installer, 60/20 is an inspector. An inspector can do your rough-in inspections. A 60/30 is a verifier. A verifier is qualified to do all of your inspections, including your verifications, your annuals. And the 60/40 is a maintenance credential. They can do annual inspections and work on your outlets and things like that. So you could get a 60/40, and then they have a 60/35, which is a bulk site specialist. And then you have a 60/50, which is an instructor. So in order to work on your equipment, you would have to at least have a 60/40. But there's a caveat to that. You can do a facility-specific training that is non-transferable to your equipment in your facility where you can work on it. That's where you can get your 60/40 online. There's several different companies that offer online things. If you don't plan on going anywhere, but you want to be able to work on your equipment, you can you can have someone come out and do a specific training on all the equipment you have there. That would be good for your facility. If you get new equipment, you'd have to be retrained. And then the question about the CO is that would be one of those type of things that, yes, you can do it yourself, but you would have to get trained by someone to how to do it. So any of whoever's doing your particular inspections should be able to sell you the kit. And then when they sell you the kit, they should be able to show you how it works, because there are several different manufacturers on CO monitors. They come out with new versions of it every year. I'm still learning myself on a lot of them. So if it would be best to get some training on it. Depending on your manufacturer, YouTube has some videos on it, but you would want to get some sort of certificate that says that you have been trained on how to do it. But if you're an outlying facility, 100%, you're going to want to have training on how to do a lot of these things. Because if you get an oxygen outlet leaking and it's leaking really bad, it would be best to be able to address that without having to wait for a company. There's not a whole bunch of medical gas companies out there. And sometimes it could take them a week or so to get out there. So if you're an outlying facility or you like to do a lot of things in-house, either in-house training or getting a 60/40 is always a good idea.
Okay, thank you. Somebody's asking, I may have missed it, but what is the Nfpa standard for pressurized tank storage? Well, that's going to be Nfpa 99.
Yep. And it'll be 20, that's your 20,000 cubic feet. So your
right.
tank's cubic feet.
Okay. All right. Let's see. I think, okay, sorry, someone was asking. So I don't have any other questions in chat. Does anybody have any questions they'd like to ask? Just unmute and ask.
And whether, just so everybody knows, the medical gas, like I said, I was an respiratory therapist and I didn't know anything about medical gas before I started. I am 100%, if you are using another company, I don't really care. I prefer for everyone to be safe. If anyone has any questions, problems, send me a picture, call me. I will gladly give free advice. I would rather give free advice all day than read about something that was very preventable because we didn't do it. I promise you, I'm here to help. And I know a lot of the companies that are out there are here to help. So if there's anything we can do, like I said, if you're having a problem, a question, send me a picture, give me a call. I'm I promise you, we want to make sure, I want Kansas to be the best medical gas facilities that they can be, because it reflects very highly on us. So please feel free to reach out anytime.
Clark, thank you. I'll just give a couple of reminders to everyone that's here. We have another session coming up on the 25th. That's going to be about the CMS 1135 waivers. They recently put out for some facilities. We'll go over that in more detail then, but I've sent out emails about that, and we'll send another one too. You should be getting them. And if anybody isn't getting the emails from me about these sessions, if you want to put your email address in the chat, I will add you to them, and you'll be getting them. You'll be getting them in the future. So I just want to say another thank you to Clark. Thank you. There's a lot of great information. You have any questions about this, you can also reach out to me. I'll put my email address in the chat.
If you want to share my information for anyone that needs, please feel free.
Sure, I can do that too.
So other than your reports and the exhaust issues and the converting to bulk storage that we discussed, what other common problems should we be looking at during these inspections occurring to medical gas? Most of the time, I feel like when we go into facilities, we're looking at your report and pretty much nothing else. Other than like your notification panels, I mean, we obviously test those and we go out and look at the bulk storage, but what are the most common things that you see that we may not be seeing?
Well, one of the biggest things is making sure, doing a quick walkthrough and going to the manifold rooms. Let's make sure they're fire rated. Obviously, that's a very big one. A lot of your older facilities will not have good fire rating. Make sure that you don't have an electric heater in there that has exposed elements. When you go to the bulk site, I see a lot of trash in them. Make sure that they're cleaning those on a regular basis and keeping an eye on that, because you don't want any flammable materials out there. As a general walkthrough, that would be my number one thing is make sure your storage locations are good. Bulk sites are the biggest thing I see of people, just because our wind is our wind, and we'll get just tons of trash and flammable things in there. Just make sure that they're keeping that clear, weeds, dead grass, things like that. And then making sure all your valves are accessible, basically, and making sure everybody's properly maintaining their equipment. I think that's the biggest thing that has fallen through the cracks, is we were just doing a lot of we were just kind of maintaining equipment. You know, I think a lot of guys were changing oil and things like that, but there's a lot of other components there. So just make sure that they're properly maintaining their equipment. So, hey, John, I also have a local number as well. I think better one. It's a 913-575-1987. That would be the best one to call. If you call that one, that's our corporate office. They'll get lost in purgatory on that.
Okay, I got you. Yeah, thanks for that tip. Appreciate it. Anybody have anything else?
And I know that's a lot of information. Like I said, please feel free to reach out. I would much rather, like I said, get 100 phone calls rather than find out about something that we missed. So the other big thing is on dental offices too. I think we didn't really touch on it much, but for you guys, you know, there's a lot of dental offices going on, and it's very vague on the storage requirements in manifold rooms. And you're going to have the same gases in there. You're going to have nitrous oxide and oxygen. So make sure that they're putting these rooms in, fire rating them, and have a proper signage on the doors and put ventilation in there, because they can fail just as easily as everybody else. So for you guys, one of the biggest things was on your level 3 stuff. And it did go to its own chapter in 18 and clarify it a little bit. But as I read it, it's still pretty vague. So it's one of those things that I would definitely make sure that you have your inspectors looking at, make sure that the storage rooms are in good working order.
I'll just mention again for everybody also, we have recorded this session. We'll have it up on our website. I'll send an email out to the ones I have been and add the new ones. So it'll just be in a couple of days. It should be up so you can review it and, slow it down and go back and listen and get all the details you need. But certainly reach out to me or Clark, we could help you with that as well. Clark,
Thank you for everything.
Thank you.
Thank you. Bye.
No problem. Bye.